So we'll start off by creating a new conceptual mass family. And you can find that under the templates, conceptual mass, metric mass. And this is going to give us the context onto which we're going to instantiate or duplicate these adaptive families we're going to create. So first we need a context. We're going to draw the kind of extents of the bridge, the Floral Street Bridge example, and the overall extents. And then after that we're going to draw splines, two splines that will be the rails that will hang the adaptive family onto. So there's first spline, second spline, and those are the two curves that will control the placement of the adaptive family. So next step is to create a new adaptive family. So can we go to our family templates, and we want to pick a generic model adaptive template to start from. And the first thing we really want to do with any adaptive family is create those points that are going to drive the rest of the model. So create these 2 points. This particular example uses 2 adaptive points. And then you'll see there's a 1 and a 2 associated. Those are the pick order of the points. So now we draw a reference line that connects those 2 points. And that's really going to give us, those planes on this reference line are going to give us the context we need to draw a lot of the other elements. So first we want to set the vertical endpoint plane, turn 3D snapping off, and create a reference line horizontal over that point, and add a point attached to that line, and set it to host point by intersection. So now when we move that point around, the adaptive point, the point above tracks that adaptive point. So that's the kind of behavior you want to see. And that gives you basically the vertical height of this bridge example profile. And we want to add a dimension to drive that height. So create the dimension and then label add parameter. And we want to make sure it's an instance parameter. We'll call it path height. And that gives us control basically over the overall vertical dimension. And then we want to also define the horizontal opening. But in this case, because the 2 adaptive points are basically driving the width of the path, we want to add a dimension that links those 2 points. But instead of driving the position of those points, we want to set the parameter that drives that dimension as an instance reporting parameter. So it's basically a passive dimension. It doesn't drive anything, it's just reporting the horizontal dimension between those 2 points. You can see it's grayed out. So that gives us a readout kind of the overall horizontal dimension. So then we want to draw the diagonal line, but it's important that you don't snap to the endpoint. You see, I just snap to the line, and then I change the position of that point. if you snap to the endpoint, I found it changes the planes on the reference line, and that kind of messes up. So now, okay, we want to draw the vertical line, and this vertical line is going to basically it's going to establish the center of our overall profile. So you see, I activated the plane on that point, and now I can start to draw the bridge profile. And so it's important, that you're very conscious of which plane you're making active when you're drawing, because that really affects the overall relationships, parametric relationships between the elements. So now we're adding dimensions to the center point and the edges. All these dimensions will be the same because we have the overall profile dimensions are equal. And so we're going to add a parameter that's going to drive all of those dimensions. Call it frame width. It's an instance parameter, so that can grow and stretch depending on the context it's in. And then we also want to add an angular dimension, and that's going to drive the rotation of the profile. So you may see in the example that the profile kind of rotates a certain number of degrees every instance. So that gives us control over the angle of the profile. And you can see we can kind of update that, say to 15 degrees, and see it update there. So that's a good sign. If it's moving around, it's updating with no constraint errors, then you know you've set it up correctly. So now we're going to add some formula, because what we want to do is make sure that the width of the profile is always as long as the diagonal dimension. So that way, as this thing rotates, it's always going to be outside of the extent of the walkway for this bridge example. So add a little Pythagorean theorem, a squared plus b squared equals c squared, and get the diagonal dimension. Of course, we're doing kind of the radius, so it's in half, but you can see now the extent of the profile goes right up to those points. So that's what you want to see, and that matches the example, the digital project example, from that's on the GT Wiki. So last thing we need for this profile is to add the actual profile of the member. So it's just a simple rectangular profile in this case. And we want to draw that, and that'll give us the profile we need to sweep the member and create the overall profile that you need. So just kind of adjust it so it's the kind of real world dimensions, and it helps to look in this work plane view when you're working every once in a while. Make sure you're set to the right work plane, and make sure that you've got all of that working correctly. And then just take this profile and center it on the overall on the overall profile, which we'll use kind of as the sweep direction. So just kind of move that up to the center there. And so now we have that, and we select the two profiles, create form, and there we go. That's the kind of final form you want to see. It's pretty simple, but the complexity is in all of the relationships, and you'll see once it's placed in the context, there's a little more going on there. So just kind of flex it to see that things are set up correctly. And so now what we want to do is we save that, and we created a second version, and we're reusing that first example to create the glazing between the members. So we create we're taking that previous example, we saved a new version, and we're selecting everything and copying that. So now you'll see once it's copied, for instance, the adaptive points are renumbered. So it's like 1, 2, 3, 4. That's you want to see that. All of the dimensions are copied, and so the only real thing then, now that you have the same lines, the same dimensions, is you need to create new parameters, a second set of parameters basically for the second profile. So that's what we're doing here now. Is we have two path heights, and the same goes for the path width. So, but since we copied it, we didn't have to redraw the dimensions and lines that we had drawn before. So that saved us some time at least. And then add that frame width parameter instance as before. And you can see all the parameters now. And just like before the formula, we need to recreate the same thing so that the next profile down is the same, reacts the same to the context, and resizes based on the longest dimension between the diagonal line endpoints. And just a second frame angle parameter there. So basically just kind of recreating the same set of parameters. So now they're independent of each other. And I resized that so they're totally independent of each other. That's what you want to see, and it's always good to kind of flex the model around to make sure that it's working correctly. So just cleaning things up a little bit. Since we had kind of had the original names, just kind of making it 1 and 2. To clean things up a bit. So now we should have our 2 profiles, and the only thing we really need to do now is create these twisted surfaces between them. We want to make sure to select that surface option. The form creation tool kind of gives you different options. So you want to make sure when you do create form that you select the surface option. And this will give you the that twisted surface that you need that represents the kind of infill surfaces between the members. So, and just to kind of make it look a little more like the real thing, I guess, just change the materials for those surfaces. So, just selecting the surfaces and update the material to some type of glazing. So just so it looks, kind of appears as some kind of infill, you know, ETFE or something of that sort. So that basically gives you the 2 adaptive components that you need for this example before you start the Dynamo portion. You'll need these 2 families loaded in the project. So now we're back at the mass family context file that we created in the beginning. And we want to make sure to load those 2 adaptive families that we now have, the Floral Street frame and the Floral Street glazing file. So we need those both in the context. So you can see now if we place them, okay, that's basically what you want to see. So at this point, open up Dynamo to automate the placement of the adaptive families. The adaptive family, we're going to start with a select curve. So we need 2 inputs. So we want to select those 2 rails that we're going to add the adaptive families to. That's the very first thing. And search tool is really pretty useful. I like it. So now we have to create a list. And a lot of these steps are come from the example in Dynamo project that has the adaptive. This is kind of a variation on that. So we want to add these 2 together using a list module, and we want that to then feed out to a module for placing the X, Y, Z points on a curve, and we have a little slider to kind of determine, how many points go on that curve. So this is basically where we can kind of automate the placement of the points. And this is a kind of a bit of confusing, but yeah, it's understandable when you look at it. You want to take the list that's created, which is basically two lists of all these points, and transpose it. So now it's a list of lists, but a whole bunch of lists that have 2 points in them. And because the adaptive family is basically, it takes 2 points. And so you have to take that list that's a list of 2 lists and transpose it into a list of mini lists where each list contains just 2 points. So then the module, the adaptive component, so this is the module actually places the family, the adaptive family, and so we want to tell Dynamo which family we're going to select, and link that in to the adaptive component by XYZ. So, and make sure that we have that Floral Street frame family selected. So you can see I just ran it just to test and see. Okay, so now it seems to be working fine. We've got them being placed. I think we had set to 20 or 15, maybe 15 frames. So now it's adding 15 frames to those rail curves. But we want to, remember we had that angle parameter, so now we want to drive that angle parameter so that when it adds each instance, it slightly tweaks that angle parameter. So we want to set the family instance parameter. We want to feed that the output, the adaptive family, into that. And we need to remember what the name of the parameter is. So in this case was frame angle, and link that to the parameter input. So it's important you remember what name you gave it. Case matters in this case, so uppercase, lowercase. And then number sequence. So if we want basically to start off, say it's 0 and then add 15 degrees each time it adds a frame. So you have this kind of twisted vortex shape. So yeah, so we have the start set at 0, and the amount is, we just linked it back to that slider we created. And because it's the same number of steps, right? That kind of determines the number of frames we're going to create. And then the step is just the interval between each. So in this case, we're going to twist the frame by an interval of 10 degrees each time. So if we kind of test that out, hit run, should see it update. And there you go. Okay, so now we have the members all instantiating and twisting by 10 degrees, just like the example, the digital project example that from a few years back. And you can see we can kind of change the rail spline. It doesn't track immediately, so you need to update Dynamo again because we're using that option of setting the adaptive point. The point is not being hosted on the line, so or spline. So if the spline changes, it doesn't automatically move with it, but it does update when you go back and hit run. So I think that works. I think that works pretty well actually for the adaptive component. So not be directly linked to those rails. Actually, it's not a bad thing. So then the next part of this, so we have a kind of overall workflow, basic workflow. The next part of this is going to be to add that that glazing adaptive family. So just to kind of test it out, make sure it's working okay, nothing breaks. Just gonna kind of manually instantiate it to see how it works. With a lot of these parametric models, you have to constantly test it out and find any breakpoints. It'll save you a lot of time if you find those breakpoints early on. So we want to take, first step we want to do is basically take this list that we originally created of a list of lists with 2 points. We want to flatten it, and the reason we want to flatten the list is so that we can create basically a list from this list which has the set points for the first, say, adaptive family. Takes 4 points, so we need to create a list which has 4 points instead of 2 points. And then that list overlaps. So the set of 4 and the next set of 4 overlap with each other because adjacent adaptive families share the same points. So with this build sublist option, basically telling it to create these sublists of 4 points, and we want to shift it, that offset number 2, we want to shift it by 2 each time. And again, we're using that adaptive component by XYZs, same as before. You know, you can actually just take the module and copy paste it. That's an easy way to do it. Then make sure to set it to the glazing family instead of the frame. And so that should at least, you know, create the glazing. But we still, just like the one before, we need to set the instance parameter. In this case, we actually have 2, right? We have the beginning of the glazing profile and the end of the glazing profile. So we need to do this twice. So again, we need to make sure you remember what the parameter name was. In this case, frame angle 1. And we can reuse the number sequence that we created before to drive the values for this second adaptive family. And then we just copy paste that module again because we need to set it for the beginning of the first profile and the second, and also the second profile. So this one is going to be frame angle 2. And the value is going to be slightly different because we're going to start at one step in. So in this case, we can just create a second number sequence module. And link that up so that the start, so in this case the start is the next step. So we're starting at 10 degrees instead of at 0 like the one before. Just kind of organizing the modules a little more. It's a little easier to look at. So now should be able to hit run, and it's regenerating. Takes a little bit of time, but yeah, all right. Here you go. Here are the they're a little transparent, so they may be a little bit difficult to see, but yeah, there's the glazing adaptive family in between. You can see twisting